Usually, when something is fundamentally broken in engineering, it's pretty obvious.
Oh, yeah. Yeah.
Usually, like a medical diagnosis, you break your arm, the x-ray shows that jagged white line, and the doctor just points at the screen and says, well, there it is.
Right. It's binary. It's clean.
Exactly,
Ah,
clean. But if you step into the world of software engineering right now, um, that x-ray machine is just completely broken.
it's giving us entirely mixed signals.
Yeah, because we're looking at a landscape where over 90% of developers
Uh-huh.
are actively using AI to write code.
Which is a massive shift.
Huge. I mean, we are shipping more code than at any point in human history. We're objectively moving like 37% faster in some metrics.
Right.
And yet developers feel like they are standing completely still. Systems are buckling. Trust is evaporating.
It's a real paradox.
So we have to ask the multi-million or maybe multi-billion-dollar question.
Right.
Is this massive investment in AI actually paying off for you?
Right. That is the question everyone is asking.
So today, we're doing a deep dive into the brand new State of AI Impact in Engineering Q2 report.
Which was just published in July 2026, for context.
Exactly. It covers April through June, pulling hard telemetry and qualitative data from over 500 organizations.
A really solid data set.
Yeah, and our mission here is to figure out exactly why the diagnostic X-ray of modern software development is showing us a system in crisis.
Well, let's just say it is the absolute definition of muddy waters out there for engineering leaders right now.
Oh, I bet.
And that 90% threshold you just mentioned, that's exactly why we are flying blind.
Wait, why does the 90% make us fly blind?
What's fascinating here is that we have officially entered what this report categorizes as the ubiquity era of AI.
Okay, the ubiquity era.
Yeah, think about how we usually measure the impact of a new tool. We use a control group, right?
Right. The classic A/B test. Team A gets the shiny new AI coding assistant. Team B gets a regular mechanical keyboard and a pot of coffee.
Exactly. And then we just see who merges more pull requests by Friday.
Super simple.
Precisely.
Yeah.
But with industry-wide adoption hovering well above 90%, that structure for comparison is completely dead.
Oh, because there is no Team B anymore.
Right. There is no control group. AI utilization is no longer a binary condition. It's ubiquitous.
That's everywhere.
It has transitioned from being an experiment to being core infrastructure.
Wow. Yeah.
And because of that, measuring things like, the number of lines of AI code generated or counting the raw tokens an LLM processed, those metrics are suddenly entirely useless for determining business value.
They don't mean anything.
They only show us how the work is changing, not if it's producing better outcomes.
Okay, let's unpack this. It sounds like you're saying AI is no longer the new experimental nitrous oxide boost in a street race.
That's a great way to put it.
Like, it's not a special button you press to go fast for 10 seconds anymore. It's just the standard fuel that everyone is putting in their tanks.
Exactly.
So if everyone has the exact same fuel, we can't just measure the fuel anymore to see who's going to win. We have to look at the whole engine.
That is a phenomenal analogy. If everyone has the nitrous, the advantage immediately shifts to whoever has the best tires,
Right.
the best suspension, the most skilled driver. In the engineering world, this means we have to stop looking at isolation metrics.
Like hours saved writing code.
Exactly. We have to ditch those and start looking at outcome-oriented frameworks.
Makes sense.
And the report we're looking at today relies on something called the DX Core 4 framework. This is going to be our North Star for this deep dive.
Okay. The DX Core 4, what are the four?
It focuses on 4 structural pillars of engineering health: speed, effectiveness, quality, and impact.
Speed, effectiveness, quality, impact. Got it.
Right?
So we're looking at how fast the car is going, how frictionless the steering feels to the driver, whether the wheels are actually falling off while we drive it,
Yeah, that's the quality part.
and whether we are actually driving toward a destination that matters to the business. That's the impact.
Exactly. Because the fundamental questions that engineering leaders need to answer haven't changed just because AI is writing the boilerplate code.
Right. The business still needs results.
You still need to know how quickly value is delivered to the customer
Mm-hmm.
and how easy is it for developers to do their work.
Yeah.
This data tells us that while AI represents a massive shift in how software is built, it doesn't alter what these organizations are ultimately trying to accomplish.
Right. Now, I have the data right here in front of me, and we're going to dive into 4 massive themes today.
The speed mirages, system bottlenecks, the crisis of trust, and the explosion of costs.
Yeah. But before we look at the specific numbers for that first theme, speed, I want to ask about how they are even measuring it in this ubiquity era.
It's a fair question.
Because if I just count how many times someone hits commit on a repository, That doesn't tell me anything about the value of the code, right?
No, it doesn't.
If developers are using AI, aren't they just generating massive walls of text? Are we actually moving faster, or are we just making a bigger mess?
Well, the short answer is yes, we are objectively moving faster.
Okay.
But the long answer is where the nuance lives. And it starts with how we measure that velocity.
Right.
The primary metric the report uses for speed is called true throughput.
True throughput.
Yeah. Now, true throughput is a critical evolution from just counting how many pull requests or PRs a developer merges.
Because, a PR could be a massive architectural overhaul, or it could literally be changing the color of a button from blue to slightly darker blue.
Exactly. You can't weigh those equally. So
Right.
true throughput actually parses the abstract syntax tree of the code. It weighs the complexity of the code diff.
Oh, wow. So it actually understands what the code is doing.
Yes. So a massive, highly complex algorithmic change gets weighted much heavier than a simple typo fix or, a massive block of auto-generated documentation.
That's smart.
It makes it a much more accurate reflection of actual cognitive developer effort translated into code.
Okay, so this is a highly filtered, highly accurate metric, and the numbers here are just wild.
They really are.
Median weekly true throughput rose a massive 37% over the last 4 quarters.
Yeah.
It jumped from 1.42 to 1.94 PRs per engineer per week.
It's a staggering spike. And I want to contextualize what going from 1.4 to 1.9 PRs actually looks like on a Tuesday afternoon for a standard engineering team.
Yeah, paint that picture for me.
On an individual level, half a PR more per week doesn't sound like a revolution.
Right, it sounds like maybe an hour of extra work.
But when you multiply that 37% increase across an engineering organization of 500 or 1,000 people,
Oh, wow.
the sheer volume of complex logic moving through the integration pipeline is massive.
It's a tidal wave.
You are suddenly asking your systems to absorb a third more intellectual output than they were designed for.
But wait, this isn't a rising tide lifting all boats equally, is it? Because looking at the segment breakdown in the report, this velocity is incredibly uneven.
Not even close to even.
Yeah.
If we connect this to the bigger picture of organizational structure, we are seeing a massive divergence based on the size of the company. Small to mid-sized organizations, what the report categorizes as 15 to 99 engineers, are absolutely crushing it.
Really? How fast are they going?
They are hitting around 2.2 PRs per engineer per week.
Wow. So they're just flying.
Yeah, but then you look at the massive enterprises, the organizations with 750 or more engineers,
Okay.
they are lagging significantly,
Yeah.
sitting down at just 1.2 PRs per week.
Wait, really? So a small team is moving almost twice as fast as a massive enterprise team?
Yes.
Is that just like bureaucracy physics?
It is largely bureaucracy physics, yeah. A smaller team can pivot faster, they have less red tape, fewer approval gates.
Makes sense.
But crucially, they usually have less legacy code to tiptoe around.
Ah, right.
AI is incredibly effective when you are building something from scratch or working in a modern, well-documented microservice.
Sure, it knows exactly what to do.
But if you drop an AI assistant into a 15-year-old monolithic codebase written in Java where the original authors left a decade ago,
Oh, man. Good luck.
right, the AI is going to struggle just as much as a human would to understand the undocumented dependencies.
It's going to hallucinate everywhere.
Exactly. So enterprises are naturally bottlenecked by their own history.
That makes total sense. But there's a really interesting industry breakdown here that completely caught me off guard when I read it.
The tech versus traditional split.
Yeah. So the report splits the data between tech companies, where building software is the core product, SaaS companies, cloud providers, and traditional companies.
Like retail, manufacturing, or healthcare, where software just supports the business.
Right. And as you'd expect, tech companies are consistently outpacing traditional industries. Tech is sitting at about 2.1 PRs a week, while traditional is down at 1.2.
Which tracks with what we'd assume.
Right. But look at the specific vertical breakdown within those traditional industries.
Okay.
If you ask me to guess the fastest moving industry, I'd say software development and IT. That's their whole world.
Right.
But they got beat. Healthcare actually emerged as the Q2 throughput leader.
Yeah, that is fascinating.
Healthcare. How is an industry famous for clipboards and fax machines outcoding pure software companies?
It is deeply counterintuitive at first glance. Healthcare is heavily regulated, much like financial services.
Right, and financial services posted the absolute lowest throughput in the entire report.
Exactly. So why the massive difference between two highly regulated sectors?
Yeah, what's going on there?
It likely comes down to how AI is being applied to the specific operational realities and friction points of those sectors.
Okay, break that down for me. What is healthcare doing that finance isn't?
Think about the nature of healthcare software. It involves a massive amount of data parsing, integrating with archaic electronic health record systems,
All right.
translating HL7 messages, and writing endless boilerplate code for compliance reporting.
Just really tedious stuff.
Exactly. These are highly specific, high-friction, incredibly tedious areas of a workflow. Large language models are exceptionally good at generating that specific kind of boilerplate.
So they just point the AI at the most boring parts of the job.
Yes. It's possible that healthcare organizations have unleashed AI on these exact tedious bottlenecks, unblocking developers at a massive scale.
Wow. So they are using AI to write the boring translation layers between a modern app and a 1990s hospital database.
Exactly. Meanwhile, look at financial services. Why are they at the bottom?
Yeah. What?
It's not because their developers are slower. It's because financial services have systemic constraints built into their release pipelines that AI cannot bypass.
What kind of constraints?
Well, if a developer at a bank uses AI to write a feature in 10 minutes, it still has to sit in a queue for 2 weeks to go through regulatory compliance checks.
Oh, man.
Security audits, staged rollouts. Agentic velocity doesn't matter if the pipeline is fundamentally rigid.
That's a great point. It's not just about writing the code fast. It's about getting permission to merge it.
Exactly.
Which brings us to the next massive metric.
Yeah.
Deployment frequency. This is a classic Diggerot metric, right?
Yes, it is.
Explain that for the listeners really quick.
For those who might not live in the DevOps world, DOOR metrics are the industry standard for measuring software delivery performance.
Okay.
Deployment frequency simply measures how often code is actually pushed to a production environment where customers can use it. Are you deploying once a month, once a week, or multiple times a day?
And the data shows this is up double digits across almost all segments.
Yeah, the standout here is the mid-sized organizations, those with 100 to 749 developers.
Those numbers to them are crazy.
They saw consecutive quarter-over-quarter growth that is just explosive, up 26%, then up 68%, then up 61%.
That is exponential acceleration. I mean, they are shipping code to production at a radically faster cadence.
Absolutely.
And there's a geographic twist here too, right?
Yeah. Regionally, companies based in Silicon Valley saw a dramatic, sudden spike in deployment cadence by Q2.
And Europe.
Meanwhile, teams in Europe, who actually started the tracking period with a higher baseline frequency, just stayed relatively flat.
Wait, why the huge gap?
It tells us that the acceleration we're seeing is heavily dependent on environment, culture, and risk appetite.
Okay.
Silicon Valley companies have a cultural mandate to move fast and break things.
Right, that classic motto.
They might be pushing the envelope, trusting AI-generated code to go to production faster, essentially using their live user base as the ultimate testing ground.
Just push it and see what happens.
Exactly. But European companies operating under stricter data privacy frameworks like GDPR might be taking a more measured, compliance-driven approach.
So they have the same AI tools, but their cultural guardrails prevent that explosive spike in deployment frequency.
You hit the nail on the head.
So if you're listening to this on your commute or while you're grabbing coffee, think about your last sprint. Objectively, the telemetry says your team is pumping out 37% more throughput.
Yes.
You are deploying significantly more often. The systems are objectively pumping out more code than ever before in the history of the industry.
Unprecedented levels.
So you should feel like an absolute superhero, right? Like you are plugged into the matrix, just bending reality to your will.
You should, but here's where it gets really interesting.
Yeah.
The qualitative data reveals a complete disconnect.
I'm looking at a metric here called the perceived rate of delivery.
Right.
The researchers actually surveyed the engineers and asked, hey, do you feel like you are delivering quickly?
And the results are completely decoupled from the objective data.
It's totally flat.
Yeah.
For a full year, despite all these massive spikes in objective output, the developer's perceived rate of delivery has been stuck at roughly 67% to 70%.
Most developers are clustering tightly in this range. They do not feel any faster.
That is wild.
This is perhaps the most vital finding in the entire first section of the report. Measurable pipeline acceleration has completely decoupled from developer perceived speed.
Wow.
Objective velocity alone does not fully indicate the total value generated, nor does it capture the human experience of that velocity.
If I'm shipping 37% more code, why do I feel like I'm running in place?
Right.
It's like Imagine you are at the airport. You're late for your flight, so you get on one of those moving walkways to speed up.
Okay.
And let's say the airport cranked the motor, so the walkway itself is actually moving 37% faster than normal.
That's a fast walkway.
Technically, your body is moving through space faster.
Mm-hmm.
But the problem is, the walkway is absolutely packed shoulder to shoulder with people and their massive, bulky luggage.
Oh, yeah. And they are all just standing there.
Exactly. So you are on a faster machine, but your personal lived experience is that you are still just shuffling along, bumping into suitcases, apologizing, feeling totally blocked and stressed out because the boarding gate isn't getting any closer.
That analogy perfectly captures the systemic friction the data is revealing.
Right?
If you are generating work faster, but you feel just as stuck, it implies that the friction hasn't been eliminated by AI. It has simply been moved to a different part of the system. The developers are the ones on the walkway.
Yeah.
AI is the motor making the walkway move faster. But what is the luggage?
Exactly. If throughput is up, but developers don't feel faster, where's all that extra energy going?
Right.
If we are getting to the gate faster, what is blocking the path?
To answer that, we have to look at how AI is fundamentally breaking the systems that surround the code. We have to examine the bottleneck shift.
Okay, let's get into it. So we just established that people are writing code faster, but feeling stuck. The report measures this overall feeling of friction using something called the Developer Experience Index, or DXI, right?
Yes. The DXI is a crucial counterbalance metric.
How does it work?
It's a weighted average of qualitative drivers. Things like deep work time, clarity of requirements, and local iteration speed.
Okay.
It gives us a comprehensive view of how frictionless and effective the engineering environment actually feels to the human beings working in it.
So it's basically measuring the vibe, but with actual data.
Basically, it's the ultimate check against the dangerous assumption that more code output automatically equals a better developer experience.
And the DXI dropped.
It did.
In Q3 2025, it was at 67. Now, in Q2 2026, it has slipped down to 65. Now, to a layperson, that might sound like a tiny little blip, a 2-point drop on a 100-point scale. Who cares, really?
Engineering leaders should care deeply.
Why?
Because of what that drop represents in hard financial terms, the report correlates these index scores to actual time. A single % drop in the DXI equates to roughly 10 hours lost annually per engineer to friction, toil, and systemic bottlenecks.
Wait, 10 hours?
Yes.
So let's do the math on that. If you are a mid-sized enterprise with 1,000 engineers, a 2-point drop in DXI means your organization just lost 20,000 hours of productive engineering time this year.
Exactly.
Because they are fighting the system instead of building features. You are paying for 20,000 hours of highly compensated engineering talent to essentially sit in traffic.
It is brutal. That is millions of dollars in payroll just evaporating into frustration.
That's insane.
Those lost hours easily nullify massive aspects of the velocity gains we saw earlier. This is why we're seeing outcomes that aren't aligned with increases in speed.
So what exactly is causing this massive loss of time? The report breaks down the DXI into individual factors, and it's a real mixed bag. Let's start with the clear wins, because I don't want to paint a picture that AI is ruining everything.
Oh, certainly not.
Where is AI genuinely making the developer's life better?
Well, the most drastic, undeniable increase is in documentation quality.
Okay.
This metric is up nearly 20%.
Wow.
And technically, it makes perfect sense. Large language models are essentially pattern matching and summarization engines.
Right.
They are incredibly good at parsing an abstract syntax tree, reading the logic of a function, and generating a human-readable summary of what that function does.
Yeah, that is like their perfect use case.
Exactly. If you are a developer diving into an undocumented 5-year-old microservice, AI can explain the architecture to you instantly. Leaders should absolutely be leaning into AI for documentation generation.
Okay, so that's a huge win.
We also saw notable gains in code maintainability, up about 3.8%, and massive improvements in production debugging.
That makes total sense. AI is great at helping you read code, figure out what it does, and spot the missing semicolon where a bug might be hiding. That's the good stuff.
Yes.
But then we look at the other side of the chart, the steep declines. And this is where the DXI drop really originates.
This is the concerning part.
Incremental delivery, local iteration speed, and review turnaround times all tanked. They dropped anywhere from 5% to nearly 10%.
Yeah. These declines are the smoking gun of the ubiquity era. They point directly to a phenomenon the report identifies as PR bloat.
Pull request bloat. Let's look at these numbers because they are staggering. The data shows that the median size of a pull request, the actual chunk of code a developer is submitting to be reviewed and merged into the main project, nearly doubled.
Doubled.
It jumped from around 42 lines of code to 72 lines of code in a very short period.
This is a critical architectural warning sign.
Why is it so dangerous?
More code generally means more complexity, less portability, and a far greater potential for introducing obscure bugs and security vulnerabilities.
Oh, sure.
Historically, a hallmark of a highly skilled senior engineer is the discipline to implement a feature with exactly as much code as is necessary. No more, no less.
Keep it simple, elegant, concise logic.
Exactly. But when AI gets involved, it operates differently. It lacks holistic architectural context, so it tends to be verbose. It over-engineers solutions.
It's eager to please.
Yes.
Like, you ask it to build a simple submit button for a form, it writes the button, and then it writes a whole new custom animation framework for the button.
Oh, absolutely.
And then it imports 3 new libraries just in case you want to change the button's shape later.
Precisely. And the developer, eager to move fast, accepts the suggestion without trimming the fat.
They just hit tab and move on.
Right. When that behavior happens at scale across hundreds of developers, the result is an immediate massive inflation of code size.
That sounds like a nightmare to manage.
It directly undermines the practice of incremental delivery, which is the healthy DevOps habit of creating small, tightly scoped, easily testable pull requests.
Yeah.
If you are submitting 72 lines of dense auto-generated logic instead of 42 lines of concise human-written logic, you are breaking the incremental model.
Think about it like 3D printing.
Okay.
If I need a lightweight box to hold some components, I want the printer to give me a hollow shell. It uses less material, it's fast, it's efficient.
That makes sense.
But AI right now is essentially 3D printing a solid block of plastic every single time.
Oh, that's a good comparison.
Right. To the end user, it looks the same on the outside. It's still a box. But it took 10 times longer to print. It wasted expensive computational material. It's incredibly heavy. And if I need to drill a hole in it later to run a wire, it's a total nightmare because it's completely dense inside.
That is a brilliant metaphor. The solid block of plastic is the bloated PR. And now, think about what happens when you hand that solid block of plastic to the quality assurance team.
Oh, man. They have to inspect the whole solid block.
Exactly. This is where the system overloads. AI is accelerating the individual output, the printing fees, but the surrounding system is just absorbing the slack rather than converting it into new value.
Because the human gates are the real bottlenecks.
They are. The code reviewers, the QA testers, the security auditors, the release managers, they are the new bottlenecks.
It's just piling up on their desks.
Yes. The report has a quote from Uman Namasivayam, an engineering leader at Dropbox, that perfectly articulates this crisis.
What did he say?
He asks, if your code throughput goes up by 3x tomorrow, would your SDLC, your software development lifecycle, be able to absorb it?
And the answer is no.
Right. He goes on to say, we have seen some early signs it is not the case. It breaks everywhere.
It breaks everywhere. That is such a stark admission.
It is.
And we see this reflected in another secondary metric in the report called ease of delivery. This measures how frictionless it is to move a piece of work from I am ready to code this to it is actually shipped and in the hands of the user.
And ease of delivery dropped by 4.2%.
Right. Because you can write the code in 5 minutes with AI, but you still have to wait 3 days for someone to review your 72-line solid block of plastic.
Exactly. Because AI cannot fix an inefficient CI/CD pipeline.
The automated pathways.
Right. Continuous integration and continuous deployment pipelines. If your CI pipeline takes 45 minutes to run its test suite, writing the code faster doesn't change that 45-minute wait.
It's still 45 minutes.
AI cannot fix a convoluted managerial approval chain or misaligned staging environments where the code works on your laptop but crashes on the server.
Or unclear product requirements from the business side.
Precisely. Non-AI factors still heavily outweigh the time savings that AI provides at the keyboard level. The systemic inefficiencies are a massive drag on productivity.
So if you are listening to this and you're an engineering leader looking at your dashboards or even a developer feeling this daily pain, the takeaway here is that you can't just buy a faster car if you are still driving in bumper-to-bumper traffic on a one-lane dirt road.
You're just going to idle faster.
Exactly. You could put $1 million Ferrari engine in your enterprise co-pilot license into your Honda Civic, but if you're stuck on the 405 freeway at rush hour, you are still going 0 miles an hour.
You have to invest in fixing the roads.
Exactly. You need platform engineering teams to build better infrastructure. You need developer portals. You need process simplification.
It's crucial.
They have to clear the traffic jams. or your expensive AI tools are just going to generate a massive, chaotic pileup of unreviewed, bloated code.
That is exactly right.
Right.
The bottlenecks have simply shifted downstream. We've hyper-optimized the writing phase, but we have completely neglected the reviewing, testing, and deploying phases.
Which brings us to a massive, slightly terrifying realization about the human element in all of this.
Right.
Because developers are generating these massive, bloated chunks of code,
Yeah.
and they're waiting longer for their peers to review them because everyone is overwhelmed with their own massive chunks of code.
Yeah.
But when those reviews finally do happen,
This is the tricky part.
right, when a senior engineer sits down to look at a 72-line PR generated by an AI,
Yeah.
do they even trust what they are looking at?
This leads us directly into a fascinating psychological tension revealed in the data. We have to talk about reading versus believing. The trust deficit.
Let's lay out the contradiction here because on paper, it doesn't make sense at all.
Right.
We talked about how the DXI showed a 3.8% improvement in code maintainability. Developers are explicitly telling researchers, yes, this code base is easier to read and understand.
Because AI is doing the documentation.
Exactly. We know AI is great at explaining things and writing comments. But at the exact same time, a metric called change confidence, which measures a developer's trust that a change they are about to make won't catastrophically break the production system, that metric fell by 6.1%.
This raises a very important question, because historically in software engineering research, these two metrics are tightly correlated.
Really?
Yeah. Usually if a code base is clean, well-documented, and easy to understand, you feel highly confident making changes to it. Why are they suddenly in extreme tension now?
Yeah, if I can read it clearly, why am I terrified to touch it?
Because of the profound divergence between comprehension and authorship.
Okay, explain that.
AI makes the code in front of you easier to read on a surface level, yes. It uses standard naming conventions, it adds comments, but because you didn't write it, and because the AI might have generated a massive 72-line block of complex algorithmic logic in 3 seconds,
right,
your faith in the validity of that output is slipping. You understand what the code is doing on the surface, but you don't trust that it's doing it safely. You don't trust that it accounts for all the obscure edge cases, race conditions, or memory leaks in your complex idiosyncratic system.
It's the difference between reading a translation of a legal document and actually speaking the language fluently.
Oh, that's a perfect way to put it.
Like, I can read the English translation of a French contract and get the gist of it, but if you ask me to bet my job, my reputation, and my company's data security on the subtle, binding nuances of the original French text, I'm going to hesitate.
You wouldn't sign it.
No way. I'm not going to sign it.
Eirini Kaliamvaku, a research advisor at GitHub, put it brilliantly in the report. She said, engineers feel deeply accountable for what ships.
Because it's their name on the line.
Exactly. She continues. When something is high risk or hard to undo, they pull back on how much they leverage agentic velocity. That's not irrational. It's human behavior that's hard to get over.
Human accountability versus agentic velocity.
Yeah.
The AI agent has no skin in the game. It wants to sprint at 100 miles an hour.
Right. It doesn't get fired if the site goes down.
Exactly. But the human engineer is the one who gets woken up at 3 a.m. by pager duty when the database crashes because of a hallucinated variable, so the human hits the brakes.
And they have extremely good reason to hit the brakes. Let's look at the hard data on quality, specifically the change failure rate.
That's another Dorer metric, right?
Yes. It measures the percentage of code changes that result in degraded performance and require immediate remediation.
Like a rollback, a hotfix, a patch. Basically, how often do you push a bug to production?
Exactly. And the report calls this the most unpredictable metric right now. It's wildly volatile.
What's the normal benchmark?
The industry benchmark for an elite performing team is a change failure rate around 0 to 15%, but broadly, teams aim for around 4%.
Okay, 4% seems reasonable.
But the Q2 data shows organizations seeing swings as of plus or minus 3 percentage points quarter over quarter.
Wait, a 3% swing on a 4% benchmark?
Yes, that means some companies are seeing an almost 100% increase in production defects.
That is terrifying.
Now, to be clear, the report explicitly notes that AI hasn't created this volatility. These underlying patterns of instability existed before, but AI has absolutely amplified them.
Well, yeah, if you are moving faster on a shaky foundation, it's going to wobble more.
Exactly. If you have poor automated testing infrastructure and you start using AI to write code 37% faster, you aren't just shipping features faster, you're shipping defects faster.
Speed without quality discipline isn't acceleration, it's just recklessness.
Precisely. And this leads us to what I consider the most counterintuitive finding in the whole report. It regards something called perceived software quality.
Yes. Okay, let's talk about this because this blew my mind when I was reading through.
It's wild, isn't it?
The researchers asked developers across all these different segments,
Hmm.
from hot tech startups to massive legacy banks. They asked, do you feel like the software you are building is high quality?
And who reported the highest quality?
Traditional industries and financial services.
The slow guys.
Yes. The ones we established earlier have the absolute lowest throughput and the most regulatory red tape. They report the highest perceived software quality, hovering around 77% to 81%.
It's fascinating.
Meanwhile, the tech sector, the companies shipping 2.1 PRs a week, deploying multiple times a day, they report lower perceived quality, down around 72% to 73%.
Right.
So what does this all mean? Hold on, let me push back on this a bit.
Go for it.
Are the slow-moving legacy banks actually doing AI better than Silicon Valley? Or is it just like a bias of low expectations?
It's a very fair question.
Because if a bank updates their mobile app once every 3 months, of course they feel safe. But they're losing the market to agile fintechs. Are they actually doing better, or are they just moving too slow to break things?
It's a vital distinction. It suggests that speed and perceived quality are not moving together, and leaders absolutely should not assume they will. But there is a structural reason for this.
Okay, what is it?
Think of it as the tortoise and the hare, but with structural guardrails.
Okay.
The tech sector hare has rocket boots now, thanks to AI.
Yeah.
But because they are moving so incredibly fast, generating massive amounts of code without necessarily fortifying their automated testing or review gates, they keep tripping over their own feet.
Right, they feel the quality slipping because they are experiencing the volatility firsthand.
Exactly. They are fixing the bugs they just shipped.
And the financial services tortoise.
The tortoise has systemic constraints that cannot be bypassed. They have to move slowly. They have highly structured rollouts, strict compliance checks, rigorous integration testing, and mandated security audits.
So they can't trip over their own feet even if they try.
Right. They're using AI carefully to fortify their shell-maybe writing tests or generating compliance reports, rather than to strap on rockets.
Ah, I see.
And because of that rigidly structured, highly gated environment, their perception of quality remains high. They are forcing AI to be a tool within a safe system rather than letting it dictate the pace of the system.
That makes so much sense. So for the listener, if you are managing a team or just trying to survive in one, this is a massive red flag to watch for on your dashboards. You have to evaluate your own quality counterweights.
You really do.
If you are in a Slack channel cheering because your deploy frequency went up 60% this quarter, but you have no idea what your change failure rate is or how long it takes to recover from a failed deployment, you are flying completely blind.
You are celebrating the speed of the vehicle while ignoring the fact that you might be driving toward a cliff. A team can actually tolerate a higher change failure rate if their mean time to recovery, their ability to instantly roll back a bad change, is incredibly fast and automated.
Right, if you can bounce back in 5 seconds, it doesn't really matter.
But if your system is fragile and every AI-generated bug requires 4 hours of a senior engineer's time to manually unravel the dense, verbose logic and write a hotfix, that speed gain you celebrated yesterday is a complete illusion today.
Which brings us to the ultimate reckoning. We have speed we can't feel. We have bottlenecks clogging our CI/CD pipelines and burning 10 hours a week per developer.
Yeah.
We have massive bloated chunks of code that we can read but are terrified to merge into production. All this leads us to the final question, the ROI disconnect.
The big one.
Is the juice actually worth the squeeze? Let's talk about the money.
The financial realities outlined in this report are incredibly sobering for anyone holding a budget right now.
I mean, let's look at the exploding cost of AI tools across the industry.
Despite the 28x increase in financial spend, the innovation ratio has remained essentially flat over the last 4 quarters.
Flat. You spend 28 times more money, and your engineering team is not spending a single percentage more time innovating than they were a year ago.
It's flatlined.
That is a brutal conversation to have in a board meeting. Now, the report does acknowledge that AI is saving time at the micro level.
Yes, it is.
It's saving over 6 hours a week on average per developer. That's almost a full workday.
It is real time saved at the keyboard. But if we connect this to the bigger picture, we have to ask the critical question. Where are those 6 hours going?
Right. If I say 6 hours a week writing the logic for a new checkout page, Why aren't I using those 6 hours to build a new recommendation engine? Why is the innovation ratio flat?
Because, as we meticulously established with the bottleneck shift and the trust deficit, those saved hours are not visibly converting into new value creation at the portfolio level.
They are just getting eaten.
Yes, they are being entirely eaten up by the new systemic friction. The developer saves 6 hours writing the initial code, yes. Okay. But then they spend 2 extra hours waiting for a colleague to review their bloated 72-line PR.
Right.
They spend 2 extra hours wrestling with a clogged CI/CD pipeline that is overwhelmed by the sheer volume of commits.
Yeah.
And they spend 2 extra hours debugging an elusive, complex error caused by AI-generated hallucinations that bypass the weak testing suite.
Wow.
The time is immediately reabsorbed by the system's inability to handle the velocity.
It's like winning the lottery, getting a sudden windfall of $1 million, or in this case, 6 hours, and immediately having to spend all of it on a massive tax bill you didn't know you had.
Exactly.
The money, the time, the advantage, it's just gone.
Gone. And there is another fascinating financial dynamic regarding who is getting the most bang for their buck.
Oh yeah, the enterprise disadvantage.
Right. You would naturally assume that massive enterprises, with their huge budgets, dedicated AI task forces, and ability to negotiate massive volume discounts on licenses, would see the absolute best ROI.
Right, they have the economy of scale, but it's the exact opposite.
It really is.
The report shows that smaller organizations, the SMBs, are actually paying more per seat for AI tools because they don't have that enterprise negotiating leverage. Yet they're getting significantly more output per dollar spent than the large enterprises.
It challenges the common executive assumption that just scaling up AI spend at the enterprise level will automatically improve your return on investment.
Bigger isn't always better.
Not here. The data proves that bigger budgets don't guarantee better returns, and in fact, they might even come with diminishing returns due to the sheer scale of process overhead in a large company.
That makes total sense.
If your system is fundamentally highly bureaucratic, pouring AI into it just creates a faster bureaucracy.
It doesn't create more innovation. It just lets you generate compliance reports and internal emails faster.
Exactly.
But it's not a total wash. I don't want people walking away from this deep dive thinking AI is a financial scam, because it's not.
No, absolutely not.
I want to highlight the biggest, most undeniable ROI win in the entire report, because this is the silver lining that leaders need to be looking at right now. It's a metric called time to 10th PR.
This is a phenomenal metric, and it's where we see the truest glimpse of AI's potential.
Explain it for us.
Time to 10th PR measures onboarding efficiency. Specifically, how long does it take a brand new developer, freshly hired, to understand the system well enough to merge their first 10 pull requests into the production code base?
And the numbers are beautiful. It dropped from 39 days down to 33 days, and in the latest quarter, down to 30 days.
It's amazing.
It has literally been cut in almost a third since before AI was widespread.
This is where AI truly shines without the baggage of systemic bottlenecks. Think about the onboarding experience.
It's usually awful.
Right. A new hire usually spends weeks asking senior developers annoying questions, trying to understand undocumented legacy code, and figuring out the internal architecture.
It's reading old wikis that haven't been updated in 3 years.
Exactly. But AI assistants and agents are incredible at navigating massive, unfamiliar code bases. They can instantly interpret legacy documentation, explain obscure internal APIs, and help a new developer produce acceptable context-aware code much, much faster.
For an engineering leader, this is hard, undeniable ROI.
Absolutely.
If you can shave 9 days off the ramp-up time for every single new engineer you hire, that translates directly into massive payroll savings and drastically faster time to productivity.
Huge.
You aren't paying a senior engineer to sit there and mentor the junior engineer on basic syntax for 2 weeks. The AI handles the baseline translation. It is a clear, massive win.
It is. But to realize wins on a broader scale, to actually move that innovation ratio, organizations have to fundamentally change their strategy.
Right.
The report highlights 2 real-world success stories that provide a roadmap for how to actually get ROI out of these tools.
Let's talk about them, because this is the playbook. First up is BNY, a massive traditional financial institution. What did they do right?
BNY succeeded because they didn't just buy 1,000 Copilot licenses, hand them out, and tell developers to code faster.
Which is what everyone else did.
Right. Instead, they used their internal developer experience survey data their specific DXI telemetry, to aggressively pinpoint the exact friction points in their life cycle.
They actually looked at the traffic jam.
Yes, they found out exactly where their developers were actually stuck. Then, they codified AI directly into those specific bottlenecks across their 8,000-plus engineers.
So what does that actually mean technically? How do you codify AI into a bottleneck?
Instead of just using AI to write features, they built specific LLM pipelines to handle the exact things slowing them down.
Oh, I see.
If compliance reporting was taking 4 days, they built an AI workflow specifically to pre-fill and validate compliance documentation.
Smart.
If change management tickets were a huge source of toil, they used AI to automate the ticket generation based on the code diff. They applied AI to planning, to compliance checks, to the unglamorous plumbing of the system.
They fixed the system, not just the code writing phase. They treated the disease of the bottleneck, not just the symptom of slow typing. I love that.
It's the only way it works at that scale.
And then there's Intercom. Intercom built an AI-first strategy that was so successful, they doubled their PR throughput in 9 months.
Doubled it.
But here's the genius part.
Yeah.
They didn't just use that gained efficiency to churn out more bloated features and overwhelm their QA team.
No, they reinvested it.
Tell me about that.
As their teams gained efficiency and saved those 6 hours a week, leadership took that windfall of time and deliberately aimed it at reducing technical debt.
Wow.
They used their faster output to fix defects, refactor old code, and upgrade legacy systems. By pointing AI at their debt instead of their feature backlog, they managed to cut their overall defect backlog by over 50% in roughly 4 months.
Yes. They did exactly what you should do when you get a windfall. Exactly. If you win the lottery or if you get 6 hours back a week from AI, you don't immediately go out and buy a boat you can't afford to maintain.
Right. You pay off your debts first.
You pay off your high-interest credit cards.
Right.
You pay down the technical debt. You use the AI's ability to read and translate old code to finally fix the foundation of your house instead of just using it to quickly build a shaky new addition on the roof.
Which brings us to the ultimate conclusion of this deep dive. The overarching narrative of the Q2 report is overwhelmingly clear.
Let's summarize it.
The data proves, unambiguously, that AI makes the act of writing code faster. The throughput metrics confirm it.
Right.
But the systems surrounding the code, the human review gates, the deployment pipelines, the testing infrastructure, the architectural discipline, that system is buckling under the pressure of this new agentic velocity.
Output is way up. But the human experience of building software, the foundational trust in the code we are writing, and the portfolio-level financial return on investment, none of those have caught up yet.
They are lagging indicators in a ubiquity era.
So if you are listening to this, whether you are a junior developer or a CTO, the fundamental takeaway is that AI adoption is not the finish line. Handing out licenses is just the starting line.
Absolutely. The organizations that will win this race over the next 5 years are the ones that realize you cannot just drop an AI tool into a broken, highly frictional process and expect magic.
You have to do the work.
Leaders must pair every single throughput or spend metric with a quality and experience counterweight. If you measure PR velocity to see how fast you're moving, you must simultaneously measure change confidence and DXI to see if you are burning out your team or breaking your systems.
Exactly.
If you measure AI spend, you must relentlessly measure your innovation ratio to ensure you are actually getting a return.
You have to look at the whole dashboard, not just the speedometer. So here is our challenge to you, the listener. Tomorrow morning, take a hard look at your own tech stack, your team's daily workflows, and your CI/CD pipelines. Are you treating AI as a magic wand that just makes code appear out of thin air? Or are you doing the hard, deeply unglamorous work of fixing the plumbing so the water can actually flow?
It's the plumbing that matters.
Are you investing as much time and budget in platform engineering, test automation, and process simplification as you are in shiny new AI licenses?
Because if you aren't actively fixing the pipes right now, the pressure is only going to build. The volume of code is only going to increase.
That's a guarantee.
And I want to leave you with one final provocative thought to mull over.
Okay, lay it on us.
It's building on a tiny, almost hidden detail buried deep in the report's methodology section. We noted earlier that AI-authored code has now crossed the 52% majority threshold in production changes.
Right. Over half the code being shipped today is written by machines.
Which is wild to think about.
It really is.
But if human jates, the senior engineers doing code reviews, are currently the massive bottlenecks slowing everything down because they are terrified of approving bloated, complex AI code they don't fully understand.
Yeah.
What happens next? What happens to our systems, to our architecture, and to our foundational trust in software when the inevitable next step arrives? When the pressure gets too high and we decide to solve the human bottleneck by entirely removing the human, and we start using AI agents to review, test, and approve the code written by other AI agents.
Oh, wow. AI writing the complex logic and a different AI signing off on the logic. The human developer is just completely removed from the loop, watching the dashboard blink green. Are we building a perfectly self-optimizing engineering utopia? Or are we just going to generate an infinite hyperspeed loop of perfectly formatted, completely unreadable bugs?
It's the million-dollar question.
That is a terrifying, fascinating question to end on, and something you should definitely be thinking about as you look at your own pull requests this week. Thank you so much for taking this deep dive with us. We will see you next time.